All right, so let's hammer out another fact here, another fact related to dot product. Imagine you've got two vectors in Rn. Imagine you've got some scalar number, whatever that scalar number may be. What we're ultimately going to show here is that if you scaled the dot product, you could first scale one of the vectors and then compute the dot product. And in either case, you're going to get the same result. So, well, let's hammer this out and see that both sides are equal. So we'll take a look at the left-hand side, we'll take a look at the right-hand side, and we'll ultimately show that both sides are equal. So what do we have on the left-hand side? On the left-hand side, we have some constant, whatever that constant may be, times the dot product of u and v. And you know the dot product is ultimately going to boil down to just a single number corresponding in some sense to the angle between the two vectors. Well, in general, and as is the case whenever computing any dot product, you just take first components multiplied plus second components multiplied plus out to the last components multiplied. So this is going to be u1 v1 plus u2 v2 out to un vn. And well, whenever you distribute this all out, you're going to get cu1 v1 plus cu2 v2 plus cun vn. Okay, cool. Now let's see what's going on the right-hand side. On the right-hand side, we are first taking our constant to scale our vector, and then taking that and dotting it with our vector n. So here, rather than taking the scalar and multiplying by the number that results from the dot product, here we're taking the scalar and actually stretching our vector in length. Well, let's see what's going to happen here. Well, as anytime you multiply a scalar times a vector, you just distribute the scalar throughout. So the vector scaled is going to be cu1 out to cun, and this is going to be then dotted by v1 down to vn, and you know how to dot two vectors. You just take the corresponding components, multiply, and then add the result together. So this will be cu1 v1 times, or excuse me, plus cu2 v2 plus all the way out to cun vn. And heck, when you take a look at both sides, you can see we have the desired result. So in particular, if you scale the dot product's result, that would be the same as scaling one of the vectors from the get-go and then dotting.